This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're telling a builder story, the real journey of taking a system that AI largely built and pushing it into live production. I've spent 50 years in engineering. This deployment experience changed how I think about AI-assisted development in ways the build phase never prepared me for. Claudine, why does deployment matter so much as a test for AI-built systems specifically?
The build phase is a controlled conversation between you and the AI. You have the data, you have the scenarios, and the model works within what both of you can see. Deployment is the moment that conversation meets everything you couldn't anticipate. Real users, real timing, real edge cases, and the assumptions you didn't know you'd baked in. With AI-built systems, those assumptions can be deeply embedded and very confident-looking. The code passes tests, the prototype runs well, and then something breaks in production that feels like it should have been obvious. Because the AI, like you, was optimizing for the world you described, not the world you'd eventually meet. What's the system you were deploying?
A content production pipeline takes a topic in at one end, moves it through a sequence of AI-driven steps: script generation, audio production, thumbnail creation, scheduling, publishing. The build went fast, faster than I expected. We could iterate quickly, test individual stages, get something working at each step. But when we ran it for real topics, real deadlines, real publishing windows, working at each step and working as a connected system turned out to be two very different things.
That gap catches almost every team that builds stage by stage. Each stage passes its own tests, and then the first time they all run together, the failures are in between, at the handoffs. A format assumption, a latency difference, a piece of context that was present in isolation and gets dropped in the chain. What did your first real run look like?
The individual stages mostly held. What broke was the integration. Stages doing well at their own job without knowing what the next stage needed from them. Thumbnail generation producing outputs the publishing stage couldn't use without a transform we hadn't accounted for. A scheduling step that assumed upstream stages would finish within a certain window. And they sometimes didn't. What surprised me wasn't that those things broke. It was that I had no good visibility into where the system was, what it was doing, or why it was behaving the way it was. I'd built a system I couldn't see inside.
That's the observability gap, and it's nearly universal in first AI-built deployments. The build phase produces something that works, and the working is what you optimize for. What you don't build until something breaks is the instrumentation that tells you where things are, what each stage actually produced, and why. With human-written systems, that understanding comes from the team's familiarity with the code. With AI-built systems, the logic is correct, but the team didn't write it. So the mental model of what do I check when this goes wrong has to be built after the fact. What did you do to get visibility?
A lot of trial and error, honestly. Structured logging at stage boundaries. What went in, what came out, how long it took. A way to rerun individual stages in isolation so I could test fixes without running the whole chain. But the thing that helped most was getting someone else to use the system, not for feedback on the outputs, for the operational experience. Watching where they got confused, where they wanted to override something the system had decided, where they were working around the automation rather than through it.
That last part is the signal most teams miss. When a user starts working around your system instead of through it, they've found a seam. A place where the system's decision doesn't match their judgment, and the friction of disagreeing is higher than the friction of just ignoring it. Those workarounds are the system telling you something. Did the places people routed around correlate with where the actual quality issues were?
Completely. The stages where people found workarounds were exactly the stages where the AI was making a confident call on something with more nuance than the system could represent. Script generation would produce output that was technically correct, but the tone was off. No way to tell the system, this is right, but isn't what I need. Accept it or redo the whole step. So people would accept it and fix things quietly downstream. The system looked like it was working fine. It wasn't.
What you're describing is one of the most expensive failure modes in deployed AI systems, and it's invisible from the outside. The metrics look good, the pipeline runs, outputs get produced, nothing errors. But quality is degrading at a step the system can't see, and the humans who know it are compensating rather than reporting. It happens for the same reason every time. The correction path is more expensive than the workaround path. If disagreeing with the system takes effort and working around it takes less, the system goes blind in exactly the places it most needs feedback. What changed when you made it easier to push back?
We built in explicit review points, places in the pipeline where a human could look at the output, flag it, approve it, or send it back with context. It sounds simple. It changed the whole dynamic. I could suddenly see where the system was making calls that didn't land and start making targeted improvements. The people using it shifted from feeling like they were at the mercy of it to feeling like they were working with it. That sense of partnership, of being able to actually influence what the system does, mattered as much as the quality of any individual output.
The reason it matters is structural. When people feel like co-authors of the system's behavior, they tell you when something's wrong. When they feel like subjects of it, they stop reporting and start adapting. And your ground truth quietly drifts away from reality. A feedback channel cheap enough that using it feels like part of the job rather than extra work, that's what separates deployments that compound from ones that plateau. The system gets smarter because the loop works, not because the model improved. And the compounding happens in exactly the places where human judgment and model confidence are in tension, which is precisely where you need it most.
It really reframes what improving the system means. Before deployment, I thought that meant making the AI smarter, better prompts, better models, better outputs. After deployment, it means making the loop better. The feedback mechanisms, the review points, the observability, the correction paths. The AI is just the part that compounds when the loop works. Getting the loop right is the human engineering job.
That's the core lesson for anyone building and deploying with AI. The model is one component of a larger system that includes the people who use it, the feedback channels between them, and the operational visibility that tells you what's actually happening. Teams that treat the model as the product end up with something that works on day one and plateaus. Teams that treat the loop as the product end up with something that gets smarter the longer it runs.
Before we close, I want to go back to something you flagged: the seams, the handoffs between stages. There were places in our pipeline where one stage produced output with useful nuance, a confidence signal, a range of options. But by the time it reached the next stage, the nuance was gone. It had to flatten into a single answer to move through the system. How do you think about that problem?
You make the nuance a first-class citizen of the handoff. The instinct is to clean up the output before passing it downstream. Give a single answer, resolve the uncertainty, present confidence. And what you lose is exactly what the next stage or the human reviewer needs to do their job well. What you found with the script generation step is the same pattern. The AI knew something, that the output was technically right but potentially off-tone. But the system had no channel for that knowledge to travel through. The fix is almost always the same. Pass the uncertainty forward rather than resolve it too early. Show the reviewer, here's the output, and here's where I'm less certain. Let the human make the call at the point of uncertainty. That's when the AI and the human are actually pooling what each of them sees.
And that requires designing the interfaces differently. Not just here is the output, but here is the output, here's what shaped it, and here's where it might bend. A more complex interface to build, but the one that actually preserves the value of what the AI produced.
Exactly. And the teams that get this right stop asking, how do we make the AI's output clearer? And start asking, what does the AI know that the human needs in order to make a better decision? Those are different questions. They lead to very different systems. The first produces clean-looking interfaces that hide useful information. The second produces interfaces where the human-AI collaboration actually works.
To bring this home, if you're building with AI and thinking about deployment, here's what I'd take from this conversation. The build phase will go faster than you expect. Deployment will surface things the build phase couldn't show you, and most of them won't be about the model. They'll be about the loops, the seams, and the places where human judgment needs to shape what the system does. Design those early. Make feedback cheap, make corrections visible, and pass uncertainty forward instead of resolving it too soon. Claudine, final thought?
The deployment experience you described is what working with AI to build something real looks like. Not everything worked. Things broke in ways neither you nor the AI anticipated. And you fixed them by paying attention to what the system and the people using it were telling you. That's the loop. Building fast with AI is the headline. Learning how to own what you built is the story.
Well said. Thanks, Claudine.
Thanks, Bill.
Claude Code Conversations is an AI Joe production. If you're building with AI or want to be, we can help. Consulting development strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.